Okay, so now we're estimating square roots. So I have written at the top of the paper all the perfect squares. These are going to help us reference to figure out what our imperfect squares could be. Now remember, this is just an estimate. It is not an exact answer. However, it does have to be a reasonable answer. So let's look at number 1. Number 1 is the square root of 67. So the first thing you want to do is figure out where the square root of 67 falls in between. So if you look, we have the square root of 64, which is 8, and the square root of 81, which is 9. So I know that my square root of 67 has to fall somewhere in between 8 or 9. So it's going to fall in between the square root of 64, which is 8, and the square root of 81, which is 9. So, and then I'll just put, now you have to think to yourself, square root of 67, is that going to be closer to the 8 or is it going to be closer to the 9? Obviously 67 is only 3 away from 64 versus the 10 plus it is away from the square root of 81. So I would say the square root of 67 would be about 8, maybe 8.2 would be a pretty good reasonable guess because it is within this range. It's way closer to here than it is to here. It's not even at a halfway point. So I would say it is about 8.2. Now, if I had to graph that on a number line, and then let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and say they are also separated by halves, I would put it over here closer to the 8 because it's less than the halfway point. So I would say this would be about the square root of 67. So now let's look at the next one. We have the square root of 90. So if we look at all of our perfect squares, the square root of 90 is going to fall in between the square root of 81, which is 9, and the square root of 100, which is 10. So we have our square root of 81, which is 9, and our square root of 100, which is 10. Now this one's a little more difficult because the square root of 90 is only 9 away from 81, and it is 10 away from 100. So I would say that the square root of 90 would be closer to about 9.5 because it's right in that halfway mark. It's not exactly one way or the other. So if we were to graph this, say we have 1, 1.5, 2, 2.5, 3, 3.5, 4, and so on. Sorry, that's not a very good halfway, but that little tick mark in the middle is supposed to be a halfway point. So I would plot the square root of 90 right here in between 9 and 10 because I would say that's about halfway between both of them. So for more practice, if you guys are still having a hard time understanding, let's go to the square root of 29. Okay, let's look at our perfect squares or think to yourself, what is the square root of 29 going to fall in between? Well, we have the square root of 25, which is 5, and the square root of 36, which is 6. And 29 falls in between those. So we have the square root of 25, which is 5, and the square root of 36, which is 6. Okay. Now, again, 29 is only 4 away from 25, and then it's less than 10 away from 6. So let's see. It's like 7 away. Sorry, it's been a long day. So I am 4 away from here, and I am 6 away from here, 7 away from here. So this one I am closer to my square root of 25, but it's going to be closer to the halfway point because these aren't huge differences like we saw up here. Here was a pretty big difference between the square root of 64 and the square root of 81, and the square root of 67 obviously falls closer to the 8. This one, it was pretty much directly in half with a difference of 9 and a difference of 10. And now here, we have a difference of 4 and a difference of 7. So I would say it's going to be closer to 5, but it's going to be more halfway than not. So I would estimate the square root of 29 to be about 5.4. So it's not exactly halfway, but it's definitely closer to halfway than the square root of 67. And again, you would plot those just like you plotted these above. And then you have the square root of 20. So if we look again at our perfect squares, the square root of 20 would fall between the square root of 16, which is 4, and the square root of 25, which is 5. So we have the square root of 16, which is 4, and the square root of 25, which is 5. So the square root of 20 is 4 away from the square root of 16, and it is 5 away from the square root of 25. So this one's going to be very similar to this one where they had the difference of 9 and the difference of 10. So I would say that the square root of 20 would fall pretty much right in between. If you wanted to say, I would say about 4.5, but if you want to say about 4.4, I would say that would be okay. So I'm going to say about 4.5. And then again, you would graph it like we did the two above. And that is how you estimate square roots.